countries, different disciplines as well, who represent a unique group for giving a perspective on such an important theme, which is biodiversity. This workshop for us is extremely important because biodiversity is essential for food security, for life as well of our planet. This includes the broad variety of plants, animals, microorganisms, as Dan already mentioned, that exist. There are genetic differences, the different communities and landscapes that they comprise, and the multiplicity of interactions that interconnect them. In agrosystems, resident agrosystems, agrobiodiversity has a crucial role because the diversity of organisms is fundamental for the functioning and provision of services of the ecosystems. In our region of Latin America and the Caribbean, it is located as one of the regions with the greatest diversity of ecosystems in the world. It has 12 of the 14 biomes, terrestrial biomes, 190 ecoregions, land terrestrial ecoregions, 96 ecoregions of sweet water, and 44 of marine ecosystems. The region also has a beautiful cultural patrimony as a result of the coexistence and coevolution, historical throughout history, between human communities and nature that has sustained them forever. We are daily more aware about biological diversity as a world good of great value for the present and future generations. The number of species and ecosystems continues to decrease acceleratedly due to human activity. For this reason, the Conference of the UN on Biodiversity, Biological Biodiversity, held in last December in Canada, was so important. It concluded with an agreement, a historical agreement of a world framework of Montreal on biodiversity, which seeks to orient world actions in favor of nature from today to 2030. Among its aims is to reestablish 30% of the ecosystems, reduce waste, food waste, and invest at least 200 billion per year in strategies that benefit biodiversity. The announcement of the so-called Open Ocean Treaty seeks conservation and proper use of marine biodiversity, being a steward for 30% of the oceans of the world as protected areas. Healthy biodiverse ecosystems that are sustainable in oceans and rivers until to the forests and plains are key for our struggle with climate change to diminish the risk of pandemics, and food security. Wetlands, forests in good status of conservation augment natural defenses in front of the appearances of new diseases, reducing the risk of new pandemics. The ecosystemic focus is used for managing integratedly the land, water, and living beings, promoting conservation and sustainable use in an equitable way. And for this, it considers the essential relationships between organisms and their environment, recognizing persons as an integral part of nature. The increase in the use of fertilizers, chemical fertilizers, pest control chemicals, and plastics has had a very negative impact on the microbiome of the soils because they've contaminated to water pollution. They've generated serious implications for human health, besides contributing to greenhouse gases. Besides this, strategic biodiversity for food security is involves a billion people in the world. Probably you don't know this. They depend on the harvest of wild crops directly from the forest. In some remote tropical zones, it's estimated that the consumption of wild meat covers between 60 and 80% of the daily needs, protein needs. And so it's key to emphasize the quality of food, healthy foods that come from biodiversity that are being revalued. And I believe that in our region, we have some important examples. One are the food tourism circuits in Peru, and the other is the basic food basket in Bolivia. These are among other practical examples that have contributed to conservation and the productive agriculture systems that contribute to practices of restoration, improve biodiversity, and they're key for maintaining it. The relationship between biodiversity and quality of life can be maybe less obvious for the immense majority of persons who currently live in the cities or urban centers and that do not gather their foods directly from nature. However, no matter how far off they may be, wildlife continues to be the base of our health and of our food diet and the first line of defense in front of the consequences of climate change. Because of all these reasons, we must guarantee um, guidelines that are of sustainable consumption, reorient the subsidies, the activities that destroy nature to the recognition of the rights of the First Nations and local communities who are the most firm stewards of biodiversity in our world, and to exert pressure on the governments and companies so that they adopt stronger steps and measures and more rapidly against the loss of biodiversity and the climate crisis. We have to work together, the governments, the civil society, the private sector, academia, in favor of a sustainable future for the planet. Thank you very much.
Thank you, Eve. Thanks for these very encouraging and strong words. Jeff,
Gracias.
without ado, please go ahead for your opening remarks. Thank you, Jeff.
Thank you, Dan. And first of all, thank you all for attending and being here in person on very short notice. We know that we were scrambling to put this workshop together, the first workshop. Part of that was because we had already established our meeting. We met here as a World Congress of Apimundia for the past 5 days. So we thought we could work that in conjunction with this workshop. But a really big thanks to Dan and the team in Rome, Monica, who worked with us, and many of you worked with Monica to arrange travel, et cetera. So thank you all for working to get here. Why is Apimundia associated with this workshop on biodiversity in agroecosystems? Well, in some sense, as Dan pointed out, we always fall in an agricultural university or whatever. Are we on the plant side? Or are we on the animal side? And in reality, we bridge both. And many of the public is aware of that. The public is aware of the importance of pollinators and bees. And so in a way, it's a perfect fit. If we're going to change the agroecosystem and make it better and more diverse, pollinators are probably a really good sentinel insect. And when I say pollinators, it includes honeybees and other bees. We as Apimundia represent beekeepers, but beekeepers are not only beekeepers of Apis, which many of us know, Apis cerana in Asia, Apis mellifera in other parts of the world, but we have beekeepers that manage stingless bees and other types of bees. And as Eva pointed out, the beekeeping is a very sustainable practice in forest and other protected areas. It's non-extractive. It has very low startup costs. Beekeepers can be in these areas and extract honey and wax. Both of those products are stable at room temperature. So they're also easy to export and gather income, which reducing poverty is one of the goals of FAO. So we think that beekeeping around the globe is a very positive activity, and it works well in any of biodiversity efforts. And we actually have a proposition to be at COP28, which is coming up this November. We will plan to be there as Apimundia and talk about the role of bees and other pollinators in helping to offset climate change. So I'd just like to close with, again, a thank you to all of you and to my Apimundia colleagues from Orawan, who will help host the meeting in the Philippines in February. David Mukamama from Africa, he'll be hosting one in sub-Saharan Africa. And thank them. Thank all of the FAO team, especially Anna here locally for all your efforts. And then lastly, thank you all for being here. I look forward to good dialogue over the next few days. Thank you.
Thank you, Jeff. Thanks very much. Now that closes our opening session, and I've seen that behind me there's already coffee has arrived. So what I would suggest while we're getting organized here for the next panel, we'll have a short break where everyone can grab a coffee. It will be really just a short break, 5 to 10 minutes, but you can have a coffee. The nice thing is we can have the coffee in the room even. That is very unusual but nonetheless, please be cautious with the coffee. Well, then the next panel will be shared by my colleague, Ana Postera Guerrera. And here we are. Thanks very much. Thank you very much, Eve, and also Jeff. Thanks.
Para las personas que nos acompañan virtualmente, por favor, en 5 minutos arrancamos.
Here virtually, in 5 minutes, we will start with the presentations. We now welcome the coordinators from the different regions and countries who are accompanying us today to listen to the different sessions, the open sessions that today we will be receiving from our colleagues Beno Freitas, De Lucas Garibaldi, Monica Kobayashi, and also Dan Leskin. So we want to tell you also that we have interpretation services, and also we have a discussion session for questions and answers. So we thank you for writing your questions as they emerge, writing them in the chat so that we can answer them during the discussion. So we welcome once again, and Breno, you have the floor.
I don't know how acquainted about pollination you are, so I prepared something in general terms, especially because Lucas Garibaldi will talk more specifically about some topics than he can, and I think that we can be more general in this initial talk. So, how does it go down here? It's not moving. No,
It's a PowerPoint, right?
it should move. It
Should
doesn't
move,
mind.
yes. It's gonna-
Okay,
Okay,
Okay.
then, yeah, sorry.
all right.
Presentation mode.
Yeah, but it is. Let's see. No, it is. Es un PDF, ese es el tema, sí. So you need to,
It's a PDF.
yeah.
But even so, you can, yeah, could you do it, Lucas?
PDF, but
Where is it?
I know that it works in PDF. I've done it before.
yeah, it will,
Yeah, see?
but it
Okay,
still is
But
not
where's
this
it?
one.
Exactly,
Okay.
where is it?
No,
No, no, para moverlo, porque no se.
no, pero
Okay,
puedes poner el PDF en presentation mode. Ah, yeah. Ahora sí.
okay, all right, okay.
It was hidden.
Right, I'm sorry for this. Well, as you probably know, most agriculture settings are poor in pollinator biodiversity. You can see in the image like that, that probably there is not many things living in there, a part of the crop. And because of that, some of the agriculture practices are unfriendly to most pollinators. Because when you do this land clearing, for example, you're eliminating places where they can nest, you are eliminating possible source of food. When we do plugging, we kill a lot of pollinators who nest in the ground, like for example, solitary bees. Large fields like the ones you can see in the bottom screen, they are very good when they are on blooming, but most of other parts of the year, the pollinators have nothing to eat there, and usually they just abandon the areas. And the same happen when you go with these pest control treatments that usually kill most of the potential pollinators in the area. We've done some years ago a study with one of our PhD students in this area in Brazil. That is the area that is sort of a soybean frontier in the country, and where you could assess the number of bees, bee species in the cerrado vegetation, that is the natural vegetation in the area, comparing to the bees that would still remain after the soybean being planted. And what we found out is that approximately 80% of the bee species were restricted to the cerrado. We found only 16 species out of the 78 collected in cerrado still inhabiting the area with the soybean. And that happened because, of course, when you remove the natural vegetation, you remove a lot of resource that is bee nest, like, for example, trees or trunks to nest in, oil resource that some bees use, and other things like that. Small and diverse cultivation areas are satisfactorily pollinated by pollinators living in the surrounding vegetation. For example, When you have a small crop like this passion fruit crop, you see surrounded by plants or by trees or by the forest, or we have this agroforest cultivation, the pollinators are more diverse and they can come and pollinate the crops, and it works fine. But when you go to large fields like that, you can imagine that when it's bloom, the demand for pollination is huge. And of course, after we have caused that impact we saw in slides, in some of the slides I've showed, we don't have many pollinators remain in these areas. And most of this crop, they demand pollinators. They rely on pollination to be productive. So why pollinator biodiversity is important to agriculture? I've listed 5 points you can see there. First, because most of the crops depends on pollination to increase yield. Some are profitable without pollination because they can self-pollinate, but if you come with pollinators, you produce more. Different plants have different pollination requirements, so you have only one type of pollinator. It may not be adequate for that crop species in particular. Pollination is an ecosystem service. Pollinators can be important bioinputs for the crops. And if we increase productivity, and this is the main point I've always worked with growers, if we increase your productivity, you have a more sustainable agriculture. You need less deforestation, less cultivated land, less carbon emissions, and it's better for the whole environment. Talking about the requirements of pollination by crops. For example, even agricultural crops capable of self-pollination pollinated by wind can achieve higher fruit or seed productivity when also pollinated by bees or any other pollinator. You can see some examples like the coconut, the castor bean, the soybean. In agriculture, bee pollination can contribute with different manners for the productivity in agriculture areas. First, increasing the crop yield. Many crops like passion fruit, cashew, coffee, tomatoes, and others will produce much more if properly pollinated by living beings. Also, it improves fruit quality because sometimes it's not only a matter of pollinating, but pollinating well. You can see some examples like sweet pepper, strawberries, apples, and pears, where you can see that the ones on your right side, on left side, are properly pollinated, while the one on the right side are not. And then, of course, these fruits, they have less commercial value than the proper one, as you expect. Also, it increased the amount of oil in the seeds. There are a lot of studies showing that when the oil crops are pollinated properly, it will yield a better harvest, especially oil content. And it also shortens the crop cycle. That means like you can, with some crops like melon, watermelon, zucchini, you can use the same area more times along the year, especially in tropical areas, and then you don't need to cultivate a different area, for example. When you talk about the pollination requirements that I mentioned, some crops, like for example, acerola, you can see there, or passion fruit, or tomatoes, or eggplants, are not well pollinated by, for example, the honeybee, or most of the bees or the pollinators you see. They have their specific group of pollinators. And we'll talk a bit later about this. This example is another study we've done, was in a project with FAO and the World Bank and the Ministry of Environment in Brazil, where we investigated the pollination of cashew. And we work in this area where you can see where it's listed forest. It's 100 hectares of forest. And then we have these other sites where you have cashew grown, some less than 1 kilometer for this forest area, others farther than 2.5 kilometers, and some close to small patches of vegetation, others with no small patch of vegetation nearby. And what we found is that for the 10 area, the 4 more productive were the ones that were less than 1 kilometer for the forest, showing the importance of the forest as a place for provide pollinators for the crops. And here you can see that when you have less than 1 kilometer, doesn't matter if you have a small fragment, it's close to the crop. This will work as a place where the bees will come from the large fragments, and they will use this small fragment close to the crop as a place to jump for the crop. They need this. You can see that it was different when you had no small fragment close to the crop. If the plantation is 2.5 kilometers farther from the forest, we found no difference at all. And here you can see the mean number of visits by native pollinators on the top graphic, and you can see by Apis mellifera in the bottom, and you can see that for Apis mellifera it doesn't make difference the distance, but for the native pollinators that have a shorter flight range, it's very important to be close for the crops. And you can see in the graph in your right that the nut yield was proportionally for the number of visits by native pollinators to the crops. If you consider pollinators by inputs, in most of the world, Apis mellifera and bombus species, especially Bombus silvestris, are already used largely as by inputs in agriculture areas. And some solitary bees like the osmias and the megachilus are now being used as well. But in tropical areas, we don't have many other options as bees to use for pollination rather than the honeybee. For example, this is strawberries being planted in a tropical state, that's the state where I live in Brazil, and where the natural pollinators of the strawberries don't occur there. So we have been testing a lot of bees, and what we found is a diversity of solitary and stingless bees visiting and pollinating well the strawberries. But the result, we even presented in Apimondia now, show that no single species is capable to maximize the yield. We need them working together, because some will just go around the base of the flowers, other will on the top, some will go in the first day the flower open, the other one in the second, and then their joint work is important, and that's why the biodiversity is important for crop pollination. You can see the result on the fruits. When there are no pollination, in your right side, pollination by bees, relying only on wind or the flower itself, and on the left, when you see visits by one single bee, it's the second from the left, and when you see all them working together. Other crops like acerola, I don't know if you're acquainted with it. This crop, it's a crop it's native from the Central America, and it's a tropical crop, very, very rich in vitamin C. Brazil is nowadays one of the largest growers, and it's used mainly to extract vitamin C. But these flowers don't produce nectar, they produce only oil. So it doesn't attract most of the pollinators. Only this special group of bees, they call it oil collecting bees, will visit the flower and pollinate. So if you don't have this bee in the area, you have no pollination. Here you see we've been working with these bees, promoting nesting sites for them, because they're native, they're already in the area. We just need to give them conditions for them to prosper, and then they will pollinate the crop, as you can see. And this is important, why? Because these bees use this oil for feeding the brood and also building the nest. But the adults themselves, had to feed on pollen from other plants and nectar from other plants. So it's not just a matter of having the bee in the area. You need to have other plants than the acerola. So as you can see in the images, we need to leave in the area plants that will provide nectar and pollen for this bee. And these plants, doing so, will attract other bees, and will attract caterpillars that will attract birds to eat it, and then you build up a sort of a biodiversity. This is a large farm. It's 240 hectares of acerola there. And now they are all using this system, and they are working with us, identify these plant species that the bee use to promote this plant in the area and enrich the biodiversity on it. The same with the carpenter bees. As you know, the passion fruit, for example, needs this large bee for pollination. But this is a very tricky bee because it doesn't nest in cavities. It nests in wood. So we have to develop a system like this one, you see, to bring these bees to the areas. And then we can pollinate annatto, passion fruit, we can pollinate Brazil nut, we can pollinate pitaya, dragon fruit, all these fruits with large flowers that the small bees are not capable to do the job. And also with weird crop for tropical areas, but now people are growing also the blueberries. And of course, we have to pollinate with, we don't have bombus there, so we need to pollinate with xylocopa bees. And to finalize, just to end, I'd like to show this experiment we did in 2010 with soybean, when no one were talking about pollination of soybean by bees because it self-pollinates. And then we worked with one area where it was netted, where the crop was netted, compared to areas where it was open, areas where we introduced honeybees. And as you can see, we have an increase in productivity. When it was net, we had 2,800 kilograms per hectare. That was the average in the world. When we remove the net, leave for natural pollinators, it increased about 6%. And then when we introduced the honeybee, but could be any other bee, it went up to 18% of increment. So, and this is interesting because actually why it grew, why it was higher, the yield, because we set flowers that otherwise would not set, and then there is only one seed, but especially because we set the third seed per pod rather than only two. And with some calculations that we did, an exercise we did at that time, we showed that with the increasing only by the wild bees, if you consider the whole area planted in the world with a soybean, that would represent something like $6.2 billion more, just because the use of the bee. While the wild bees plus the honeybee, it would be over $17 billion. But the most important is that to reach this productivity that you see in this slide with the productive that we had in the world in those days, 2,800 kilos of hectare, it would be necessary to expand the cropping area over 18 million hectares. And in 2010, when this work was done, the cultivate area in the world was over 100 million hectares. And then in 2017, it reached 120 million hectares. That was exactly the 18 million hectares plus we have considered. That means in only 7 to 8 years, we devastated 18 million hectares that in theory, it would be not necessary if you could improve the yield, just having more diversity, having bees in the area. And one point, important point, in this study, the grower applied the pesticide as he used to apply. We didn't ask him to do something different, okay? So, why I'm using this not update data from 2018? Because that production was when you reach this amount of land, deforestation, but the most important thing is that you produce more, you had planted more area, but the productivity was lower than 10 years before, right? And so my final remark is that pollinators are important by input for an ecosystem approach to biodiversity for food and agriculture. That means we can do things, not only managing the pollinators, but also do things in the area. Lucas will show that, Hien will show that we can attract these pollinators, you can manage them and have a more diverse and more productivity area with less, without the need of more land. Sorry, I think I talked too much.
Muchas gracias, Breno, por la presentación. Por favor, si hay preguntas, Anótenlas para el momento de terminar las 4 presentaciones que tenemos previstas para hoy en la mañana. Pasamos justamente
Please, if you have questions, write them down for Breno and persons accompanying us. 300 persons are accompanying us virtually. Please, the questions in the section of chat. Now we'll move on to the next presentation. We move on to the presentation of Lucas Garibaldi. Lucas is the main consultant of the National Council of Scientists, CONDICET, in Argentina, and he will speak to us about production and the policies of biodiversity.
Okay. Bueno, muchas gracias.
Thank you very much. I will begin with bad news because of the problem, or one of the problems that we have. And later, my talk will mainly be about solutions to this great problem. And so here you have a graph, and what you see is the loss of species through time for amphibians, mammals, birds, reptiles, and fishes. And what you see is that we're continually losing more species, but there's something extremely important that we can see here, which is it's not a straight line, but it's an upward curve. This implies that destruction is growing. We always lose more species and more quickly. On the planet, species have always appeared and disappeared, and the species that should be extinguished, according to what we can expect, is the gray shadow that you see below that you can barely see. Those are the species that should appear according to the habitual rates. What you can see is what's happening on the planet and faster and faster. What I want to say is that the balance is clearly negative. Though there are actions that are positive throughout the world, they're not being well done because species are being lost more and more quickly. And so this is, and the bees are not an exception. The same thing happens for diversity and abundance of bees and of pollinizers. And I don't know if you knew, but if you think of the honeybee, there are more than 20,000 species. There are many native bees in Latin American countries, an incredible diversity. What is coming? Before a species disappears, individuals in the population are lost. So we have a kind of deer before the species disappears, our first 1,000, and so deer will disappear. So what we have to do is monitor the populations and the individuals. And this is what we have, the populations for 5,230 species, 31,821 populations. This is what's happening through time. And above, you can see it's clearly negative. And here the time window is a little smaller for the last 5 decades. And increasingly, we have less abundance in wild animals and populations. And obviously, there are different variations for different groups. For example, what we see a little less, for example, the freshwater species, this is even worse. And so this is also quite alarming and important with respect to what is coming. Now, the question is if this is a problem of a small percentage of the population that likes to go and look at animals, life in nature, the answer is no. We live in an ecological system, whether we like it or not, and that system depends on biodiversity to work, no matter if we live in big cities, above all in Latin America. where most of the population live. We've classified these benefits as 18 after many years in political and scientific platforms. And these rows that you can see, you don't need to see the detail, but what we say is that these 18 aspects, some are of regulation, regulation of the climate, of the acidification of the ocean, quantity of water, soil quality, and food and feed materials. And there we get to 18. We quantified what happened in the last 50 years. And there are different categories. We will focus on the colors. Orange is bad and blue is good. What's happening is that the loss of biodiversity implies that the planet is losing its capacity for sustaining human life, basically. And it's losing its capacity for sustaining, creating the conditions that we need for human life. So this is not a problem of nature lovers only, but of all persons on planet Earth. And naturally, this problem is heterogeneous among groups of living beings and between regions and so on. You see here a simplification of what has been happening to the populations of wild species through time in 5 regions. And look at what would be worse. Clearly, it's the region where we are, Latin America. And look at the rate of destruction of populations has been the worst in the last 5 decades. If we look at the spectrum of time, the patterns are different. But clearly, in the last 5 decades, Latin America has suffered the greatest reduction in abundance of wild individuals and populations. Now, what is the main cause of this loss? The main cause is how we produce it in forests, in animal production, and in our crops. Always, what is our vision as a humanity? It's the scale, economies of scale that does not contemplate biodiversity. So what we want a lot of abundance and little diversity, a lot of tree species, but just one. And the same thing with the animals, a lot of cows of just one race, breed, and so on. The same thing with the herbaceous plants, many individuals of one species, soya or sunflower. We do this regionally throughout Latin America, and it becomes the principal cause of the reduction of diversity of life in Latin America and on the planet. And if we add the chemical fertilizers, it gets worse. And so production based on economies of scale doesn't consider biodiversity. It's based on little diversity and few inputs. And so what is the solution for this? We need other systems of production. What we are working on for years now is redesigning these production systems in which instead of more production is based on more diversity of life. Where we use fewer inputs. And so in agriculture, we don't just work with crops, but we become protectors of nature, managing the borders as ecological reserves. So we're not just interested in crops, but in managing the habitats or landscapes in a complete way. So this is one of the things that we do in many fields in Argentina and other places of the world. And these redesigns that we're working on together with producers, agriculture and livestock breeders, we redesign these lands, and they have ecological corridors and restoration of natural habitats. And what's most interesting is that this causes productivity to rise. So we have dysfunctional landscapes, we have monofunctional landscapes. In the homogeneous landscapes which predominate, we concentrate on just one function, production, the commodity, short term. So we want wood in 20 years, or milk, or meat, or soya, or wheat, but just one thing. And the multifunctional landscapes, we want to harvest wood, but we want to clear the air. We want to provide clean water and a lot of services. We want to spend less too, buying less agrochemicals. So we combine multiple functions and benefits for society. And here I won't talk much about the experiments. I'm just talking about the benefits. Paradoxically, they are crop productivity for for agriculture and livestock, better quality in production, and more pollination, less costs. So if you buy less things, because the lands from destructive become regenerative, so they produce more and more of the things they need. And there are benefits, not just of one dimension, because it's very good to produce soya, but there are also benefits in multiple dimensions. So here we have an experiment in different parts of the world. We've done this also together with FAO. We have worked in Africa and Asia and many places with producers in fields with real crop data, and we raise the production by 24%. That's a lot, some less, some more, but never negative. When we generate these multifunctional landscapes, we are near nature, and this is good for agro. There are other experiments that are more focused in Argentina, where this, particularly sunflower, there were a lot of crops throughout the world. Here we have 500 fields, the real data in Argentina, and they're focused on the left. You see it's something that rises. And so what rises is to the left, we have the homogeneous landscapes that you see with large squares, and to the right, multifunctional that are more heterogeneous. In the graph, you have 24% green. When you move from the left to the right, you harvest more in just one field. And these are data of the companies themselves. They are in multifunctional lands, and they harvest 24% more than those who harvest in homogeneous lands. This is very interesting. To the right, you have the same process. You see that it goes down. What's shown is how the size of the lot reduces the productivity. Here in economies of scale, what we've done in Latin America and the world is to have parcels that are bigger and bigger machines. So everything's easier. This is an advantage, obviously, but we didn't realize the disadvantages from the perspective of ecology and biodiversity. And clearly, to the extent that you increase the lot size, I harvest less per hectare. And these results are quite impactful. Here we have soya studies. I repeat a little what Breno said. It's a review of many studies throughout the world, 21% on average, in some places more, in others less. For example, Breno's was less. But soya depends in pollinizers, and it's a principal crop in Latin America. In Argentina, you have 20 million hectares of soy. The potential of reestablishing biodiversity and generating more production is truly fabulous. And why these multifunctional landscapes offer more productivity? For many reasons. Breno mentioned them. I don't want to repeat. One, Breno said, it's reflected by this photo. We create these large landscapes of monoculture. So our form of agriculture is the best combination for producing a deficit in pollination, because we generate landscapes with millions and millions of flowers that bloom very soon. And so in this way, we kill the pollinizers. And so a lot of supply and little demand will generate the deficit. And besides, we control the genetics and the water, but we don't think of the pollinizers. So the deficit in pollinizer will be even bigger. And so we need, we have little pollen in the flowers, not flowers in the pollen. And so, as Breno said, after decades of investigation in many places, this serves a function for the economists and agriculturists. As Breno said, pollen can be thought of as a bio-input in agriculture, like nutrients like water, light. Plants need pollen. What you see here is that there's not just one productive function, but the productive function also depends on biodiversity. And what we see here for different crops is that when you have more diversity, you're in the curve above. There's more productivity. And the more you put in abundance of just one species, you'll never reach the upper curve if you don't have biodiversity. And this is key. And once again, it surges from field experiments. We've seen this in many places, and restoring the borders of the crops, as you see here. We have the shared border in the landscapes on the right, homogeneous, and a restoration of borders 5 years later. You see, it is restored. See the graph on the right. So in all these practices of restoration, these are important field functions, and there are many benefits in multiple dimensions. And these aspects of biodiversity that you could also use for pollinizers, or as an example of biodiversity, is to how to improve the health of the pollinizers and human health through different ways. For example, nutrition, production, medicine, but also mental health. That is more and more important. There are more and more studies in this sense. We believe that we are very rational. We take decisions based on benefits and economies, but this is demonstrated as not very good for mental health. And pollinizers, as an indicator of environmental health, the diversity is lost through time, and it's for sure that there's contamination of the water, of the land, of the foods. It's early alert for what is happening. And in this sense, as
So I want
final
to
benefits, I
show
want to
you
show
the
you how
less
the companies have
costs.
less function.
So one of the main problems of agro today is the weeds that are resistant to herbicides. So we put the poison and they don't die. So this is what you see in time. To the left, we will see how throughout time different weeds are resistant to glyphosate, and to the right how they are resistant to all the main active ingredients of the herbicides. So this is a big problem in agro. So we work with more than 10,000 farmers in the field for maize and soybean, and two charts with lines that go down for maize and for soybean. And once again, we go from homogeneous landscapes to multifunctional landscapes. So what is dropping? What is dropping is the proportion of weeds that are resistant to herbicides. In the multifunctional landscapes, there is 3 times less resistant weeds. We can then discuss about the mechanisms through which this happens, but you need to buy less herbicides. This is less cost and less problems. So now, going to the implementation and finishing my talk, there are barriers to the implementation of these multifunctional landscapes. There are different types of barriers. What is one of the barriers? One of the barriers is knowledge. We say that homogeneous landscapes require very little knowledge because they are simple. This is economies of scale. It is a very simple technological package. You can call the company and you tell them what they need to do. You purchase the same chemicals, and large surfaces are managed in a simple manner. In the multifunctional landscape, we need to buy less things. You spend less, but you need to think more. It is less intensive in the use of inputs, but it's more intensive in the use of knowledge. So we need to plan in the medium and long term. And in this sense, science and knowledge appears as a fundamental role, as well as the traditional knowledge. And this is the way we work by doing training and also providing tools. Here we have many tools and models using satellite information For example, mathematical models, geospatial models, and what you see to the right is different types of landscapes and what is the consequence in these pollination maps. We can design the landscapes and we can know the pollination maps, and this will translate into productivity, not only of the crops, but also what will happen to the native plants, how much honey will be produced in one place, how the bees will grow or not, and we can do it the other way around. What will happen to biodiversity if we don't do this? And in different parts of the world, as you see on the left, we can go from areas that are brown and lifeless to those that start having some green with different algorithms and ecological principles and generating the biodiversity. So we have found that in most places we can restore more than 20% of the area without losing money. Of 100% of the field, more than 20% could be a natural habitat without losing any money, but rather winning money. And in some places, up to 50% or more. This is important from the political point of view to meet the targets that the countries here present are committed to achieve. For example, the biodiversity framework in Kunming, Montreal that they signed for 2030. It is an adjustment of 30% of the restoration of the habitat. This is what we're doing to do ecological corridors. And it will be impossible to reach net zero emissions by 2050 if we don't restore the biodiversity. We have different protocols. We do this in different fields in different areas of the world. You have some examples here or of how you go from these monoculture crops to the right, where you see the biological corridors and the restorations. And this is a process that continues in time, identifying opportunities for restoration. Many places are being planted without knowing, but we use a lot of precision agriculture. And we use the greatest technologies available today, where the producers lose money without knowing in different parts of the fields. And these are the ideal opportunities to create biological corridors. This is a map of the yield of these land lots in 8 years, and where we design the ecological corridors, the opportunities for conservation are much greater. So in this idea of economies of scale, we treat many large portions of the planet without respecting the natural heterogeneity, and this provides a lot of negative consequences. And here we see this, how you see different areas in the fields where you lose money without knowing. And this occurs everywhere, in the US, in Europe, in many places. So we monitor biodiversity and the pollinizers specifically. This is a picture of Argentina, where we don't see it very well, but basically if you take a small percentage of where you see the scale down in the map. So we have 13 kilometers, and there's a lot of towns inserted in a sea of monocultures. There is no life because the cities and the towns are inserted in areas that don't have life. And this happens in a large part of Latin America. So our dream is to transform this into this. This is a talk that we had with one of the fields last week, where we are talking about the concept of environment, heterogeneity, corridors, and restoration, where we are generating restoration in many places. And here you see the world map. The red is bad, so here we see all the places in the world to restore. The red areas mean more than 80% that is cultivated, and where there is no life remaining in the agricultural areas. And this is where we need to start doing these actions. Thank you very much. Thank you, Lucas. This is a very interesting presentation. Now we will go to Monica. And I forgot to tell you that you only had 15 minutes, but well. Now we go to the presentation of Monica. Monica, do you hear us? Can you hear me? Can you share your presentation, please? Can you see the presentation? Could you put it in presentation mode, please? Do you see the notes or the presentation? Yes, we see your notes.
¿Y ahora?
Está bien.
Now? Okay. So 15 minutes, Monica. Okay. Thank you. It is a pleasure to be here today. And there is a lot of pressure after the two great presentations of Breno and Lucas. So I'm going to try to connect the dots, and they have actually helped me a lot. So,
for delivering my presentation in English, but feel free to ask any question in Portuguese or in Spanish. Thank you. So today I would like to start discussing some global challenges and then giving an overview of the Kunming-Montreal Global Biodiversity Framework. And then we will focus on the targets related to biodiversity for food and agriculture, and then finally discuss the next steps. So the global challenges. Right now, we are facing many important crises, like the water, biodiversity loss, climate, and pollution crisis. At the same time, we need to produce more and more food for the growing population with these very limited resources. So in this scenario, we are also working to defend the human rights. For instance, the right for food, the right for clean and water and sanitation, and more recently, the right for a healthy, clean, and sustainable environment. And if we look closely at this intersection, we can see the role of food and agriculture for first, mitigate and adapt for climate change. Second, to increase food production by closing the yield gaps through a more efficient agriculture production system, as we saw in the two presentations, and also to better manage the water use and the use of other external inputs like pesticides and the excess of nutrients released in the environment. So all these, we will reduce the impact on biodiversity. Sorry. Yeah, sorry, I have too many screens here. So as you know, we now have many current unsustainable agriculture practices that are important driver of biodiversity loss. So the loss of biodiversity impact our future in this planet, as well presented by Lucas and Breno. We need an urgent response to the biodiversity crisis that we are living right now. In the Global Biodiversity Outlook 5, provide us some pathways to bend the curve of biodiversity loss and put our planet back on a recovery path, including through the conservation of genetic resources, the reduction of drivers of biodiversity loss, and also through a sustainable production system. So one pathway is to go on this sustainable food system transition. This brings me to the next point. With this sense of urgency to bend the curve of biodiversity loss, last December, countries adopt the Kunming-Montreal Global Biodiversity Framework. So to achieve the 2050 vision in live in harmony with nature, we achieved the mission to halt and reverse the biodiversity loss. But we need actions beyond our usual constituencies that usually is the environment community. We need to engage all of you, like the pollinators that Breno showed. We need to work together. So the framework has 4 goals and 23 targets. And it aims to drive an urgent and transformative action by all societies, from governments of all levels. For this, we need to enhance collaboration and synergies at local, regional, global, and national levels. We need to work closely with partners like FAO. The 4 goals very quickly. Goal A is about the conservation of genetic resources, the ecosystems, the corridors, protect areas. Goal B, it's about the sustainable use of biodiversity. Goal C is about access and benefit sharing. And goal D is about implementation and financial mechanisms. So this framework has a human-based approach, and it's people-oriented. The targets are interlinked, which invite us to break silos and also to have this multi-stakeholder in a more holistic approach. Due to time constraint, I'm not going into details, but let's focus only on the targets relevant for biodiversity for food and agriculture. So agricultural biodiversity was adopted, this term was adopted by COP, and it's a broad term that englobes all genetic resources relevant for food and agriculture, and also includes the ecosystem services that are fundamental for agriculture productivity, like the pollination that Breno showed us, but also for nutrient cycling, water cycling, pest control, and many others ecosystem services. Similarly, FAO has this term for agriculture or genetic resources for food and agriculture that also is based on the variety of genetic resources, include animal, plants, and microorganisms. So we have all these domesticated crops, livestock, and fish, as well as wild species that is important for nutrition for many people worldwide. So the status of biodiversity for food and agriculture is that need close attention, because like the biodiversity in general, they also suffer many threats, including from the unsustainable agriculture systems. So we need also to work on this particular subject. And what is the role of biodiversity for food and agriculture in bending the curve of biodiversity loss? As Lucas explained very well, we need to redesign our agriculture systems and transform them from the major driver of biodiversity loss to a system that work together, that will help us to bend this curve, to conserve the genetic resources, including for food and agriculture, in the ecosystem services that they need and they rely on. In a summary, the Kunming-Montreal Global Biodiversity Framework has a target 10, which deals specifically with agriculture, aquaculture, fisheries, and forestry. In summary, this target aims to make sustainable use of biodiversity through sustainable practice, like many that we just saw this morning, and also to guarantee food security by conserving and restoring genetic resources, and also the ecosystem's functions and services. Some indicators, we have the headline indicators that is about the proportion of agriculture area under productive and sustainable agriculture, but also we have other indicators that are relevant. For example, the Agrobiodiversity Index, the Red List Index on wild relatives in domesticated animals, also the pollinating species, and also the proportion of local breeds classified as being at risk of extinction. Target 10 on its own cannot drive the change. So we need to connect target 10 with other targets. We could go through that whole 23 targets and make connections. But today, I would like just to highlight some that are closely linked. For example, target 4, it's about the genetic diversity within and between populations of native, wild, and domesticated species, and maintain their adaptive potential, including through in situ and ex situ conservation and sustainable practices. Target 6 is about invasive alien species. Target 7 is about all sources of pollution. Target 11 is about ecosystem services. But also, we can connect with target 1, effective area management, as we saw clearly in Lucas' slides, the importance of this planning and have all areas under spatial planning or other effective management planning. Target 2 is about ecosystem restoration, but just a parenthesis here, we really first need to prevent ecosystem degradation because it costs much less. And then target 9 on the sustainable use of wildlife and wild species. Target 16, which also is really important, it's about sustainable consumption, including reduction of food waste. In target 22, it's about indigenous people and local communities and gender responsive participation. So this is a few examples how to connect agriculture with some targets. So now what's next? We are facing many challenges and we can transform those challenges into opportunities. For example, the need to increase variety of our food, the food that we consume globally. The food insecurity in hunger increase. The fertilizer in oil price increase. The excess of nutrients lost in the field. The high rates of food waste and loss. All these challenges can foster the transition toward a more sustainable food system. So, which benefits we can get from biodiversity for food in agriculture?
Sonido, no te escuchamos. Te perdimos la última parte.
Ok. ¿Me escuchan ahora? ¿Sí? Ok. Sí,
Can you hear me now? Yes? Okay.
Which benefits we can get from those targets related to biodiversity for food in agriculture? So we can increase production and also have more fresh food and nutritious food. We can use local varieties in neglected crops or animal genetic resources for achieving food security and nutrition. And also we can reduce the biodiversity loss, ensure food security, and also adapt the genetic resources to climate change and other challenges. And at the end, also, we could potentially save money, as we saw also in the previous slides or in previous presentation. So what's the way forward? It's about implementation. All parties are now developing their own targets and also their national indicators. We need partners with different expertise to bring on board different constituencies and then build together this collective effort to help countries on the implementation. We need coherent actions to address multiple global challenges. We need to work together like the pollinators. So just let me build a little connection to the next presentation by them. That's the actions that we need are very much linked with this framework for action on biodiversity for food in agriculture. As the FAO report in 2019 highlighted that the populations are declining. Also, our food system has become more and more homogeneous. So many genetic diversity that are important have been lost. So this action is pretty much linked to the biodiversity framework So when together, we can support countries to promote and enable this transition toward the more sustainable agri-food systems. And this regional workshop is very important. So thank you, the Commission of the Secretariat, for this important discussion. Just to conclude, the takeaway message is that we have all these global challenges, but we can build synergies. We all recognize the fundamental need to guarantee food security. And also we recognize that the global agriculture production can be more sustainable. The global challenge cannot be seen as a dichotomy like food security versus biodiversity conservation. As Lucas said, we need, agriculture is very close to nature. And nature is good for agriculture, but actually agriculture depends on Mother Nature to be functional. So the Montreal Global Biodiversity Framework can be a tool to support countries to connect the dots, to create this synergy, and to implement coherent policies regarding biodiversity and other policies, including the ones related to food systems. So we need to leverage synergies to achieve all the Montreal Global Biodiversity Framework targets and also the Sustainable Development Goals, because we cannot leave anyone behind and we need to live in harmony with nature. Thank you very much.
Gracias, Mónica. A ti. Si puedes dejar de
Thank you,
compartir.
Monica. If you can turn off your mic then.
Mientras tanto, pasamos
Meanwhile,
a la presentación
let's move on to the presentation of Dan, who will speak to us about what was mentioned by Monica, which is the Agreement of Action for Biodiversity. Dan, you have the floor.
Thank you, Anna. So I give the last presentation in this panel, and I have the pleasure of presenting the framework for action on biodiversity for food and agriculture. But before I do that, I want to briefly recap the process the Commission on Genetic Resources went through to arrive in 2021 at this framework. The Commission's decision to look into biodiversity for food and agriculture, I alluded to that a little bit before. That decision, however, goes actually back to 2007. In 2007, the Commission adopted for the first time a multi-year program of work, by the way, as one of the first bodies of FAO. And it decided that once it had concluded all the state of the world reports on plant, animal, forest, and aquatic genetic resources, it would produce a report on the state of the world's biodiversity for food and agriculture. So what is biodiversity for food and agriculture? For the purposes of the first report on the state of the world's biodiversity for food and agriculture, we've defined biodiversity for food and agriculture as the variety of life at genetic, species, and ecosystem levels that contributes to agriculture and food production. And it includes the domesticated plants and animals raised in crop, livestock, forest, aquaculture systems, harvested forests, but also aquatic species and other wild species that's harvested for food and other products. And biodiversity of food and agriculture includes what is known as associated biodiversity. So the huge number of organisms that live in and around the agricultural production systems and contribute to their outputs. For example, pollinators, which have been mentioned, soil microorganisms, invertebrates that keep our soils fertile, natural enemies of pests. That's all part of biodiversity for food and agriculture. So one can probably spend hours discussing the different definitions in this area, like agrobiodiversity, agricultural biodiversity, and so forth. But for sure, I don't want to go into this kind of lengthy definition debate. But I'm showing this slide to explain that the Commission, which originally had focused very strictly on genetic resources, and in fact, historically, the Commission had focused on plant genetic resources, that the Commission, with its decision to look into biodiversity for food and agriculture, sort of decided to widen its horizon, to widen the scope of its work. And it decided to include categories of biodiversity it previously had paid no attention to. So when you look at it, the Commission started, if you like, with the green circle, the plant genetic resources, which is nowadays covered by the International Treaty on Plant Genetic Resources. And it then widened its work to go even beyond genetic resources for food and agriculture, and now covers associated biodiversity like pollinators, like soil microorganisms, and also regulating and supporting ecosystem services. The report on the state of the world's biodiversity for food and agriculture was prepared between 2013 and 2019. As I said, the initial decision to produce the report was taken in 2007. And during this period, between 2013 and 2019, regional consultations of the national focal points for BFA were held, including for Latin America and the Caribbean. I'm sure some of you attended the regional workshop held in 2016, I think it was in March, in Panama City. Like all the State of the World reports of the Commission, the preparation of the State of the World report on biodiversity, food and agriculture was a country-driven process. A total of 91 countries submitted country reports. More than 1,300 experts contributed to these country reports, and 27 reports from international organizations, 5 thematic studies, and also the reports from the regional consultations obviously contributed to the final report on the state of the world's biodiversity for food and agriculture. And the preparation of the final report, the State of the World report, which FAO launched in 2019, involved over 175 contributors and reviewers. So the report also, of course, makes use of the other State of the World reports, the reports on plant, animal, forest, and aquatic genetic resources, which the Commission has previously produced. And I think it's fair to say that this report was a major success. It attracted widespread media attention. Just within the first week after its publication, 530 articles and major news outlets were published, and these are just the articles that were published in the UN languages, which somehow confirms a demand, possibly also a public demand, for the agri-food sector to look more closely into this whole issue of biodiversity, including biodiversity for food and agriculture. Now, what are the key messages of the State of the World report? Biodiversity for food and agriculture is indispensable to food security. It is essential for sustainable development and also for the supply of many vital ecosystem services. The country reports also highlighted the importance of biodiversity to efforts to address the challenges posed by climate change and other threats. And many country reports, in fact, emphasized the role of diversification in promoting resilience, improving livelihoods, and supporting food security and nutrition, which sort of reflects very well the presentations also by Lucas Garibaldi and Breno Freitas. Although limited, the data available from the country reports FAO received and from the wider literature points to declines in several components of biodiversity for food and agriculture at all levels, at genetic, at species and ecosystem levels. And there are a few key figures presented on the screen, which is almost impossible to read, I guess, but we will of course make all the presentations available to the participants. Countries emphasize that knowledge of associated biodiversity, in particular, the role of microorganisms and invertebrates for ecosystem services, that knowledge clearly needs to be improved. And although in certain countries monitoring programs are established for various components of BFA, in general, these programs remain rather limited. The analysis of the country reports and of the wider literature also indicates that BFA is affected by major global trends. And these trends obviously include climate change, but also international markets, consumer demands, demography, which give rise to drivers such as land use change or pollution and overuse of external inputs, overharvesting, and also, of course, the proliferation of invasive species. The drivers mentioned by the highest number of countries as having negative effects is changes in land and water use and management. And demographic changes, urbanization, markets, trade, consumer preferences are reported to have a strong influence on food systems, often with negative consequences. But such drivers are also reported to sometimes open new opportunities to make food systems more sustainable, for example, through the development of markets for biodiversity friendly produced products, food products. So policy measures and advances in science and technology are largely seen by countries as positive drivers that offer ways of reducing the negative effects of other drivers, but they provide critical entry points for interventions supporting sustainable use and conservation. However, often policies intended to promote the sustainable management of biodiversity, food and agriculture are rather weak when it comes to the implementation, as is so often the case. Now, the use of a wide range of management practices and approaches regarded as favorable to the sustainable use and conservation of biodiversity, food and agriculture is interestingly reported to be increasing. 80% of the countries that reported indicated that one or more of the practices of which they were invited to report are being used in one or more types of production systems. And there are examples of such practices are presented on the screen. Again, hardly possible to read, but we will make the presentation available. Now, although countries generally indicate that the impact of the biodiversity-focused practices on diversity are perceived to be positive, they also emphasize in all cases the need for more research in this regard. And efforts to conserve biodiversity, food and agriculture in situ and ex situ are clearly increasing in general, but the levels of coverage and of protection are often not adequate. And finally, the fifth and last key message, the enabling frameworks for the sustainable use and conservation of BFA remain insufficient, and they need to be established in many cases or strengthened in other cases, according to the State of the World report. And legal and policy measures explicitly targeting wild food or components of associated biodiversity are not very widespread. And the reasons for this include often a lack of awareness among policymakers, but also many other stakeholders that are sort of relevant to the management of biodiversity for food and agriculture are not really aware. Now, frameworks for cooperation at the national and regional and international levels in the management of genetic resources are quite well developed in the individual sectors, for example, in the plant sector. But cross-sectoral collaboration and multi-stakeholder collaborative activities, specifically targeting, for example, associated biodiversity, are obviously much less widespread and need to be expanded and strengthened. Now, the report, the State of the World report, concludes that there is a need to address the knowledge and data gaps that exist, it seems, across all categories of biodiversity for food and agriculture. There is a need to establish or improve effective policies and outreach measures to support the uptake of management practices that sort of sustainably use biodiversity to promote food and livelihood security and resilience. There is a need to tackle the underlying knowledge, resource, and policy-related constraints to the establishment of effective in situ and also ex situ conservation programs. And we need to improve cross-sectoral collaboration and multi-stakeholder engagement and cooperation in the management of BFA. And this is also why to these workshops, we are also inviting not only the national focal points for biodiversity, food and agriculture, but also at least some selected national focal points for biodiversity under the Biodiversity Convention, because we believe that these links need to be strengthened between the two communities. So what needs to be done? The framework for action on biodiversity was developed in response, as I explained, to the State of the World report. The Commission decided rather early that it needed to respond to this report. And in 2021, after several rounds of virtually held consultations, because at that time we had the pandemic, so we held these consultations virtually, the Commission and subsequently the FAO Council endorsed the framework for action on biodiversity for food and agriculture. It's important to note that the framework, like the Commission's global plans of action, is not legally binding. It's also clear that countries implement the framework as well as the GPAs, the global plans of action, in line with their own needs and priorities. On the other hand, the global plans of action and the framework for action are negotiated documents, and they're adopted by the FAO membership, which commits itself to take action to implement these documents. And so while they are not legally binding, they are clearly an expression of political will, even though, of course, their implementation depends on a number of important factors, including the availability of the necessary financial, but also human resources. One key messages of the framework for action is that to implement the framework for action, one needs to implement the global plans of action on plant, animal, forest, and aquatic genetic resources. The global plan of action on aquatic genetic resources was actually adopted at the same session when the framework for action was adopted. Genetic resources for food and agriculture obviously form an incredibly important part of the Commission's work. They also form an important, a key component of the framework for action on biodiversity for food and agriculture, and therefore the effective and efficient implementation of all the GPAs is an inherent component of the implementation of the framework for action. Now, just to run you quickly through the framework, it contains 3 strategic priority areas, one on characterization, assessment, and monitoring, one on management of biodiversity for food and agriculture, and one covering institutional frameworks for biodiversity, food and agriculture. And actually, we brought copies in English and Spanish of the framework for action with us. The strategic priority area 1 addresses actions addressing particularly the characterization, assessment, monitoring of BFA, but also monitoring of the drivers that change and affect the status of biodiversity for food and agriculture. SPA 2 addresses the promotion of biodiversity-friendly practices, including the improvement of the conservation and restoration of biodiversity for food and agriculture. And SPA 3 addresses capacity building, but also awareness raising, the strengthening of legal and policy frameworks and of incentives, and also of the improvement of cooperation and funding. So the framework, as I mentioned, is a negotiated document. It is quite high level, and I guess many practitioners may find it sort of needs more meat. It needs more detail. It needs more explanation. And I think one of the purposes of these regional workshops is to add that meat, or at least to identify the things you believe countries need to be able to implement the framework for action. And we therefore very much hope that a result of these consultations and of this workshop will be that you come up with a clear idea of what is needed in general, but also more specifically from FAO and from the Commission on Genetic Resources to facilitate the implementation of the framework for action, including all the global plans of action, and to facilitate the cross-cutting, cross-sectoral collaboration between the different sectors with a view to better implement the framework for action. And with this, I would like to end, but just let me say that if you look through the agenda, you will find the different strategic priority areas quite clearly reflected in the agenda. So in going through the agenda of the workshop and in working through these different strategic priority areas, you will be able to provide inputs and provide advice to the Commission and FAO as to what needs to be done to enable countries to better implement the framework for action on biodiversity, food and agriculture. Thank you very much.
Muchas gracias a Dan y al resto
Thank
de
you, Dan, and the rest of the panelists. It has been an excellent introduction about the workshop, and they have dealt very systematically and with a lot of synergy, all of these topics. And out of the 500 persons that have been here virtually, there are 2 questions for you, Breno, but I think that for other panelists, because they apply. And the question, Breno, is how does the lack of public policies that are efficient affect the implementation of these types of actions or sustainable projects? The second question for you to do it very briefly is what dimension is being prioritized with these actions? The stability, the availability, the use, or the access of safe and quality food products?
Well, about the first part of the question, of course, the fact that we don't have much public support or government support on this aspect is really difficult. Even for example, to do research in this area, like we work, sometimes it's that very hard to get some finance, some money on it. And the main problem that we have, I think we have, is come from our backgrounds. I'm an agronomist, right? But I was never taught pollination in the university. And I can say that it's not a problem in my university in particular, where I studied, but throughout Brazil and throughout many countries in the world. It's people more or less forget that everything we grow, we need the seeds, we need the fruits. Even the crops that we don't need, we don't eat the fruit or the seed, like for example potatoes, but we need the seed to grow it, the lettuce and other things. And then we are taught everything about how to prepare the land, how to irrigate, how to fertilize, how to deal with the pests, even the post-harvesting. But it seems that the pollination is something that comes for granted. Maybe because it's ecological service that came through years when we have very small pieces of land and you have the forests around providing it. So we got used to have it for granted. And it doesn't work like that. So it's difficult to, when you go up at the government levels, to have support for such policies, sorry, because even the people who are there, if they are politics, they don't understand about this. If they have their consultants, usually they were not thought that, so they don't think this is important. It's like this, the soybean is a great example. We have huge areas of soybean around the world, and people just think that, oh, because it's self-pollinated, you don't need pollinators, you know? So this is really a question. And for what level is the second part of the question. Well, it would be wonderful if it would be at all levels. This is the aims we like to go. Maybe it will be not for my generation, but I hope that one day we will achieve it.
Gracias, Breno. Lucas, alguien de los, no sé si quiere.
Thank you, Brando. Lucas, somebody else wants to add something? I don't have any other questions. So before closing this session, I would like to recap these 4 presentations. I think that one important thing that comes from these presentations is the fact that biodiversity, as Breno said, goes from the seeds, the pollinizers, the microorganisms, that is to say, the biodiversity that we see and we don't see, like the one in the soil. Everything is relevant for production, but it is relevant for the quality of that production. So this is a topic that is articulated. So I think that we need to provide it relevance. The other important thing that emerges from the presentations is that the loss of biodiversity is greater and faster than its capacity to recover and adapt. So I think that in this sense, it is very important to start taking actions and to identify what we are doing wrong so that we can improve this for the benefit of biodiversity using a logic of a system or an ecosystem, so that we try for this curve to be less with a less slope. Unfortunately, we see that Latin America is a leader in something that is not positive. We are leaders, particularly in the loss of biodiversity. So hopefully in the next 5 decades, we can revert this situation. I also think that it is important, and we see this in the need to generate data, to generate evidence, because in this sense, we will be able to generate information not only for those who are interested in biodiversity, but also for those who manage the costs is relevant. So in this sense, we need to generate evidence in that area that has to do with income and costs. This is important, particularly if we are talking about actors in the public, in the private sector that need to be involved, but also for those authorities that make decisions and design policy. So this is important information to generate. I think that, I think that Monica mentioned this, and all of you mentioned it, this needs to be looked at as a system. There are synergies, there are needs to articulate, and there's a need to generate enabling conditions. And in this sense, these enabling conditions, if we use the logic of a system, needs to be worked as a function of the productive ecosystem and to generate functions or alternatives that go from the water management, soil management, pesticide management, the integrated pest and disease management, but also from the logic of restoring those landscapes, as Lucas mentioned, that serve for the nests, as well as areas to protect the different types of biodiversity. And under these logic of bio or multifunctionality, where the benefits are 2 ways, benefits for the ecosystem and benefits for us as well. So the synergies have to do also with the knowledge that we have, the technologies available, the public policies that accompany these processes. But also we need to understand that these are actions that require a lot of time and we are already late. So I think that this is important. We need to start acting. So there's another type of synergy that Monica mentioned, which is the need to be coherent, have articulation and synergies between the different conventions, the climate change convention, biodiversity, also forest restoration, desertification, and the management of water resources, the responsible management of pesticides, and the different international commitments that the countries have assumed. So this is a way to not do it in isolation, but also as an ecosystem of enabling conditions that will allow us to deal with this subject in an articulated manner.
And here it's also important, based on the logic of public policy and planning, and the need to integrate the themes of biodiversity as an indicator in the quality of productive ecosystems. And so how we are changing the type of indicator so that it can be moved from and through actions as well. And so the panorama that was seen this morning requires technical assistance, public policies, skills, but not the usual ones, but rather to attend to the type of demands that we have in the conditions we are in that allow us to forecast, to project, but also to take decisions. In this way, we close the block of the morning and we thank the almost 500 persons that have accompanied us virtually. I think that this proves the importance of this theme, and I'd like to share that in the page of events, we will be sharing the presentations. You have access. We will share the link. And tomorrow we will also have another series of presentations, new topics. And so we will be expecting those who are virtually accompanying us at 11 a.m. Chile time. Thank you very much. A round of applause, please.